Hi guys and welcome to my channel. Myself Dr. Akshay, and in today's session I'm going to be discussing about the topic gain of a negative feedback mechanism. So if you guys want to learn more about the functional organization of the human body, then click subscribe and the bell icon. So let's do this together. So coming to the topic gain of a negative feedback mechanism. So before explaining the topic gain of a negative feedback mechanism, I would like to give an introduction regarding what is negative feedback mechanism. So negative feedback mechanism means it consists of series of events, and those series of events always tend to normalize some abnormal factors towards its normal mean value. So the best example is increase of blood pressure. If blood pressure increases, then this baroreceptor system, which are found at the walls of aorta, at the bifurcation region of the carotid arteries, they will sense that increased pressure, and these pressure sensations, that impulses, will be sent towards the medullary region, and from the medullary region it will inhibit the vasomotor center. After that, what will happen? After inhibition of vasomotor center, what will happen? Then this will lead to vasodilatory effect, and thus decreasing its increased blood pressure towards its normal mean value. So this is an example for negative feedback mechanism. So coming to the topic gain of a negative feedback mechanism. Gain of a negative feedback mechanism is the degree of effectiveness with which a control system maintains its constant condition, or it is the measurement of effectiveness with which a control system maintains its constant conditions. So for understanding this gain of a negative feedback mechanism, I would like to give you one example. Consider one person, okay, and his baroreceptor system is not functioning properly. Okay, so consider one person whose baroreceptor system is not functioning properly. So let the normal blood pressure be 100 mmHg. Okay, let the normal blood pressure be 100 mmHg. So in this case, we are transfusing large amounts of blood into his arteries. So what will happen? Blood pressure will rise to its maximum value. So that is, blood pressure has raised up to 175 mmHg. Since here baroreceptor system is not functioning, this value won't go back to its mean normal value. Again, consider another situation or another case. In this, that person's baroreceptor system is functioning properly. Here again, normal blood pressure is 100 mmHg. Here also we are transfusing large amounts of blood into his arteries. Here also, like this, blood pressure raised up to its maximum value. Since here baroreceptor system is functioning properly, this increased blood pressure will always tend to return back to its normal mean value, that is 100 mmHg. But what happened here? It didn't return back to its normal mean value, that is 100 mmHg. Instead, it returned back to its value, that is the 125 mmHg. So what happened here? If the baroreceptor system is 100% effective, means when blood pressure has been raised, it should go back to its normal mean value. But here it didn't went back. There occurred an error of extra 25 mmHg. So from here we got an error, that is plus 25 mmHg. So next thing, Observe these two conditions. Here, in both cases, at the initial state, pressure was normal, that is 100 mmHg. But after measuring in these two cases, difference occurred. Why? In one case, baroreceptor system was not functioning properly, and in another case, baroreceptor system was functioning properly. So, there occurred a correction when we are observing these two values. So, what's the correction? The correction is equal to final value, that is 125 mmHg, minus initial value, that is 175 mmHg. So what we will get? Negative 50 will get. So this is the correction applied. So we got two variables. One is error and another one is correction. So can you tell me the equation for gain? Equation for gain is nothing but correction applied divided by error. So that is, correction applied is negative 50 and error is 25. So what we will get? Negative 2. So I have a question. Is this system highly effective? No, this system is not a highly effective control system. The reason behind that is this 2 value is of lower magnitude. So that means the gain will be of lower magnitude. That shows that the system is not a highly effective control system. And one more thing, the gain is dependent upon 2 factors. The first one is correction applied. If the correction applied is of larger value, then the gain will also be of larger value. And if the error applied is of larger value, the gain will be of smaller value. That's because this gain and the error is having inverse proportionality relation. And this gain and correction applied is having direct proportional relation. That's the main reason why the gain always increases when correction applied increases. So that covers the topic, gain of a negative feedback mechanism. I hope you guys learned about this particular topic. Thank you so much guys. Love you all guys. See you guys in the next session.